Right, folks, so this topic, hazards of high and low pressure. I've gone for a nice dramatic slide to kick us off. This is a kind of standalone part of the module. It slots in anywhere. It's not really in the modules as such, so you will need to take notes on a piece of paper or Word document or whatever. Hazards of high and low pressure. So what I want you to do from this is just take some notes. You won't find that you write oodles and noodles, but I'm also going to introduce some case studies because, of course, if we are answering exam questions about the hazards of high and low pressure, to get a really good mark, what we want to do is we want to prove our point by using case study evidence. And so I'm going to introduce you to a few case studies. Very much just an intro, I'm afraid, but I have included loads of hyperlinks that can point you in the right direction to get some information, okay? So your mission is to watch this, take some notes, and then go off and do some case study research, please. Okay. Hazard. We use this word quite frequently in geography, and it's very important that we know what it means. So it's anything with the potential to cause harm. It doesn't mean it's going to cause harm, it just means it could. Volcanoes, wet floors, high pressure, low pressure, hurricanes, whatever. Anything with the potential to cause harm. And we are going to try and apply this idea to high and low pressure. So, very boring slide, and you can add as much or as little writing to this as you feel that you need to. Low and high pressure are the very opposite of one another. Low pressure is when the air is rising. High pressure is where the air is sinking, and they give you completely different weather conditions, which I've included for you to look at. Now, what you could do at this point is use this as a little revision opportunity to remind yourself about why you get completely different weather conditions. I will do a very, very brief reminder. Low pressure is when the air is rising. If the air is rising, the air cools down because the higher up you go in the troposphere, the cooler it gets. We've talked about lapse rates before. And in the air, there is water vapour. Water vapour is the gas form or the gaseous form of water. Water can occur in 3 states. It can be a solid, ice. It can be a liquid, water. It can be a gas, water vapour. And the 3 states of water are entirely controlled by temperature. Therefore, as the air rises, the water vapour condenses either into liquid droplets or solid particles, and that gives you clouds. Once you've got clouds, you could well get precipitation, all right? You won't always get precipitation from clouds, but it is impossible to get precipitation not from clouds. So they sort of go together. And you may want to use this as an opportunity to revise warm clouds, cold clouds, and condensation nuclei, which we've talked about in year 1 and in year 2. But I shall leave that decision up to you. You also get wind because if the air is rising, it has to be replaced, and all the wind is air moving to replace the air that's rising. Now, low pressure are storms, it's hurricanes, it's depressions, it's bad weather, it's the weather that generally makes the headlines, if you like. And it makes the headlines because it's dangerous, it's hazardous, if you go back to that bit of terminology. Flying debris, so if the wind starts to damage things, some things will be flying around in the air, like slates off roofs and signs and all sorts of things, and that can be dangerous. Trees may well fall over. That's a very dangerous thing. That is quite a big killer of people, unfortunately. Flooding from the rainfall. Coastal erosion, because of course if you've got high winds, you're going to get large waves, large destructive waves, which are going to cause lots of erosional problems. And you're also potentially going to get storm surges. Now, we learn about storm surges twice in A-level geography. We learn about them in coasts, and we learn about them in this module. We'll revise them when we talk about hurricanes or tropical revolving storms. Storm surges are coastal flooding, and it's when the low pressure means that the sea level rises and then the wind pushes the water onto the land, and they tend to be a big killer of people. Low pressure is dangerous, but people kind of forget or ignore the fact that high pressure is also quite dangerous or hazardous. And I think that might be kind of a British thing. I don't know. It's hard for me to kind of contextualise that because I am British. But I think because we get a bit fed up with the wind and the rain and stuff, when we do get an anticyclone or some high pressure and we have clear skies and it's not windy and it's not rainy and we're like, oh, this is lovely, we can maybe forget that actually high pressure is very dangerous in a completely different way. So summer anticyclones, you can have extreme heat, which can be dangerous in itself. You can get severe sunburn, prolonged exposure can lead to skin cancer. You can have drought, which of course would affect farming and ecosystems really quite badly. And then winter anticyclones, again, because the air cools down, you can get morning fog, and that can be incredibly dangerous for driving conditions. If you've driven in thick fog, you'll know exactly what I mean. It's terrifying, really, because what fog is it's droplets of water suspended in the air. It's basically cloud, but down here instead of up there, and it's really hard to see where you're going, so that's dangerous. And then of course ice, people slip over on ice, cars skid on black ice. High pressure is dangerous as well, but for very different reasons. So it's just important to get your pressures the right way round in terms of the weather they bring, and then to get your hazards the right way round. Okay, so what I'm going to now introduce you to is a series of case studies or examples that would prove these points. If you were writing an essay about the dangers of high and low pressure, you could back up your explanation with these. So, the 1987 storm. It's quite a long time ago now, so why do we still talk about it? We talk about it because it's the worst storm to hit the UK in living memory, so it's still noteworthy for that. And right at the end of this video, I'll also be talking about how the 1987 storm was a bit of a turning point for meteorology. So you can see on the screen an image of a weather forecaster called Michael Fish. And poor old Michael Fish was doing the weather forecast the day before this storm hit. And you're very welcome to YouTube his weather forecast of that day. If you put in 1987 storm Michael Fish, you'll get loads. And it's famous because he says something like, "This evening a lady phoned the BBC and told us there's a hurricane on the way. Don't worry, there isn't." And then you cut to images like the one at the bottom of the screen where like the UK's just been decimated. And the Met Office they didn't get it wrong so much as they didn't get it right. They failed to realise that the 1987 storm was going to affect the UK. They thought it was going to mainly affect France. So they didn't warn people about it. And it's a bit like the Nevado del Ruiz of volcanology, where volcanologists are like, we cannot let that ever happen again. We have got to get better at this. And then all sorts of things happen, and we get much better at monitoring, prediction, and evacuating people who live near active volcanoes. This is the kind of equivalent of that. The 1987 storm makes the Met Office really change things. So we'll talk about that a little bit more at the end. So it's a big, important case study. It is mostly notable for the wind speeds, okay? We're going to look at the 2014 storms in a minute, which are notable for the flooding and the coastal erosion and the storm surges. You focus on the 1987 storm for the wind, please, because that's what caused most of the damage and killed people. I believe it's something like 15 million trees were felled by the 87 storm. There was no electricity in London and many other places, but you just try and imagine the capital city of the UK is without power. It's a crazy storm. A ferry gets washed onto the beach by the wind. It really is quite insane. So I've included 3 of the kind of best hyperlinks there, which I'm not going to open now. The first bullet point is to a Met Office overview, which they are quite honest about, so don't worry, they're not hiding. The second one is quite a nice, it's they look 30 years on at kind of what happened. And then the third bullet point there is from an A-level geography student who's put together a case study, Joe Blakey, and it's quite a good one actually. So have a look at those, watch a couple of videos maybe. If we do get a chance, I've got a really good DVD all about the 1987 storm, but unfortunately it's not available on the internet. So that's the focus of that one. The 2014 storms we have already talked about a little bit, and these will be much more familiar to you, of course. These are the ones where the jet stream kind of got stuck over the UK. And I tend to think of the jet stream as like a conveyor belt of bad weather. So you get storm, storm, storm. Wherever the jet stream is, the places underneath that are kind of being battered. And the jet stream just hung around over the UK for the winter of 13-14. And because of that, we had flooding of the Somerset levels, which some of you may well have been affected by. We had so much coastal erosion that we lost the train line down at Dawlish Warren. You can see the photographs at the bottom of the screen. So the focus of these ones is flooding and coastal erosion and storm surges. The BBC web link talks to you quite a lot about the storm surges. The Met Office one is really good to explain why we got so many storms one after the other, and that one is focused on the flooding of the Somerset levels. So I've given you 2 low pressure systems because they both sort of prove slightly different points. It should also be said, even though you won't find massive death tolls, every website you ever look at is different. It's about 20 people were killed by the 1987 storm, and I think it's maybe 0 or 1 for the 2014 storms. So you can argue that because the Met Office got so much better at monitoring, predicting and warning people about what to do, that the death tolls were reduced. But I just want those of you aiming for A's and A stars, the 1987 storm was all over and done with overnight. So it didn't really start until about 10 p.m. and it was over by the following morning. It was a very short, sharp depression. And there is quite a strong argument to suggest that if the 1987 storm had happened during the daytime or lasted longer, the death toll would have been far, far, far higher. So you could argue that actually, that we did see a massive reduction in deaths because the 2014 storms went on for weeks, months, and we hardly had any deaths. It kind of proves that we've got better at managing low pressure. Okay. Now, that's far too many hyperlinks, but what I've just tried to do is give you plenty, and you can pick and choose if you fancy watching videos or if you fancy looking at websites. But those 2 need to be your biggest case studies, the ones that you know the most about for low pressure. All right. Okay, we move on to high pressure. Now, this is not a very nice case study to talk about, and for some of you it might be a little bit close to home, for which I do massively apologise. The reason I use it is because it proves the point about fog so awfully well. So if you've not heard of this, there was one of the worst crashes in UK history on motorways happened near Taunton. That is the River Tone here. There's the rugby club, Sainsbury's is up here. Yeah, it's one of the worst crashes ever, and it happened because of fog. And fog is created in anticyclonic or high pressure conditions. So you don't, this is like a name drop, a sentence maybe. It just simply proves that fog makes driving incredibly dangerous. And yeah, you can just add it. So tragedy, but does prove the point, unfortunately. Again, small example. You don't have to do 2019. I went for 2019 because you will have lived through it. So you might even remember the glorious summer of 2019. It's just a summer anticyclone, gorgeous weather, all very nice, but it did lead, you can actually see it in the hyperlink, look, to almost 900 extra deaths. Heat waves do kill people, unfortunately, and it just proves that point. And then finally, sorry about the quality of that image, it's a bit grainy. That the brown means much less precipitation than normal, and the blue means more than normal. So you can see that the vast majority of England and Wales received significantly less precipitation than they would normally expect in 2011, and that led to drought. Now, drought is annoying for people because you get restrictions, like you're not allowed to have baths, you might have a hose pipe ban, etc., etc., but it's really devastating for ecosystems and farmers. So you could just have a little bit of a synoptic link to the primary sector and things. But again, it's a small example, 1 or 2 sentences we are expecting. Which brings us, always, once we talk about hazards, we finish with, well, what are we going to do about it? And we always come back, time and time again, to our 4 options. Yet again, ladies and gents, we are going to repeat ourselves. Move away. Can everybody move away from high and low pressure? No, absolutely not a chance. No. Do nothing? Well, that's the idiot's option, isn't it? Doing nothing means, well, I'll just wait and see what happens, and that might end quite badly. Modify the hazard means stopping the hazard. Can you stop the atmosphere? No, you absolutely can't. Which means we're left, yet again, with modifying vulnerability, which means you know you're going to get low and high pressure, but what you're going to try and do is make sure that when these systems happen, you are not going to be too affected by them. And we've said that over and over again in geography. You are generally left with the 4th option. And what that is down to for high and low pressure, ladies and gents, is weather forecasting. If you can tell people what's going to happen and you can tell them what to do to minimise the impact of that on their lives, that's the best thing. The last time we talked about that was in earthquakes, where we talk about, you know, the value of education. Why do we have fire drills at schools and colleges in the UK? Well, because if a fire ever did break out, hopefully, if you've practiced enough times on what you're supposed to do, you kind of go into autopilot, and that should save lives. Weather forecasting enables the government, the media, the Met Office, whoever, to tell us what to expect, and then we can actually take action on that. And it might be, if they predict flooding, that the Environment Agency then get ready to put in pump stations on the Somerset levels. Or if they're forecasting a major heat wave, you can warn people to stay indoors and keep themselves cool and all of that kind of thing. Educating people is always a good idea. So I've included a few bits and bobs here. So that one is a really brilliant YouTube from the Met Office, which is, it's slightly over 60 seconds, but anyway, how do they do a weather forecast? And then this is information about the weather warning. So if you've ever heard them talk about a yellow warning or an amber warning or a red warning, Red is danger to life. That's like pretty serious stuff. That's all of that. And it all comes back to this. So in 1987, we have this great storm, this terrible storm, and it makes the Met Office think about how they can be better at forecasting the weather. So they are now really very good at it. It's quite hard in the UK because our weather changes so much that it's really tricky. They're very accurate with sort of the next 24 hours, but the further ahead you try to go, the less accurate they are able to be. But that's because the atmosphere is complicated. And I'd imagine you have figured that out from this module already. So just to have a little couple of notes about how forecasting has changed since 1987, and that's basically the way we modify our vulnerability. All right. So I'm just going to mention this now. I don't necessarily want you to do anything about it. I'm just mentioning this. We will, at some point, be introducing the idea of the key concepts in geography. Your teacher may already have mentioned them to you. The key concepts are the sort of cherry on top of your essays. And one of them is vulnerability. The idea that some people are more at risk of bad things happening to them than others because of a whole range of factors. One of those factors is development. One of them is about how much warning they're given by their government or council or whoever. One of them is wealth. It's nothing that is not obvious to you already as geographers, really. So I'm just going to mention this, and we'll come back to it in the future. On page 59, there is a table, and it talks about Europe 2003, which was our last major heat wave, and the Sahel, which is a region of Africa, in 2012. Now, if we get to development in an African context this year, we will be looking at a part of the world called the Sahel quite a lot. And essentially what happens in Europe 2003 and the Sahel 2012 is they have high pressure systems, they have anticyclones. Both of them have fairly catastrophic impacts in terms of deaths and drought and all those sorts of things. But what you begin to notice very, very quickly is that the impact of that in the Sahel is so much worse. And that's because of the vulnerability of people in the Sahel compared with the vulnerability of people in Europe. It just begins to introduce that idea to you a little bit. All right. So that is it for today. Yeah, hope you enjoyed it, folks. Thanks very much.